Intro to Statistics, Dot Plots, Histograms, and Stem and Leaf Plots. The first statistical data we'll look at today is the dot plot. It consists of data plotted with solid circles on a fairly simple scale, like a horizontal number line. Each dot represents a single data point, and all of the data values are known. Here's an example of a dot plot. You'll notice that there's a single dot above the number 65, and there's 4 dots above the number 70. So if we were to start to write out each of these data points, we would start with a 65, and then we would write 70 4 times in a row. And we could continue listing the data using these commas to separate them. The dot plot really allows us, though, to see a trend. We see that the highest number of values are in the 70s here, and that there are 3 single points at 65, 85, and 100. And we can kind of notice that the data goes up and down. So visually, a dot plot can help you see any trends. You can also quickly identify some important statistical measures, like a median or a mean. Let's take a look at an example. This dot plot represents the number of pets owned by students in a class. If you were asked to find the minimum value, or the lowest value, we could see that it's 0. 2 students in the class have no pets. If you were asked to find the maximum, or max highest value, you could see on the far right that it's 1 dot on the number 6. So 1 student has 6 pets. If you were asked to find the median, which is the middle value when you order all of the numbers from least to greatest, then you'd have to write out the digits like I did here. 0, 0, 0, right, 1, etc. And then you can cross off 1 data point from the bottom and 1 data point from the top, 1 data point from the bottom and 1 data point from the top, until you get to the middle. If there are 2 numbers left in the middle, then you would take the average in the middle of those. Now 3 and 3 are a repeat, so that means the median is 3. Another type of statistical data plot you can study is called a histogram. This is different than a bar graph, even though it does use bars. In this example, the histogram has bars that touch each other. Notice there are no spaces between the bars. And that's important, because down here, this scale represents an interval, where the 61 and the 71 touch the next interval of 71 to 81. So a bar graph uses bars that are separated with space in between. But a histogram cannot have any space in between because it shows the boundary of when you move up into the next interval zone. Now, what's different about a histogram than a dot plot is we don't actually know the data that's in here. There are several numbers between 61 and 71, and we don't know what they are. We just know that there are 5 numbers in this interval. In this second bar, we can see it reaches up to 3, so there are 3 values in that interval. Again, we don't know what they are. And here there are also 3, and in the last one there are 4. If I asked you what the mean was of this data, you'd have to say, you don't know, because we don't know the actual data points. If I asked you what was the median, again, you'd have to say I don't know, because I don't know the actual data points. But if I asked you which interval contains the median, that you could figure out. Since I'm asking for a section of the graph where the middle data point would lie, we could still use that same strategy of crossing off numbers from the lower end and numbers from the higher end, like this. And as I cross them off, equally 1 from each side of the data as I move, I'll notice that the last point is located here. So that means that the middle value, whatever it is in the interval from 71 to 81. The last plot we're going to look at is the stem and leaf plot. This organizes data by place value. The stem will contain the tens digit, and the leaf will contain the ones digit. A stem and leaf plot is a combination of a dot plot and a histogram, sort of. So you can see the exact data values, like a dot plot, but you can also quickly observe the intervals of the data like a histogram. Let's take a look. In this stem and leaf plot, a stem of 6 represents 60. So anything in this row starts with a 60. So the first data point is 65. The second data point is 68. So I can see the actual data, right? Not just a dot to say there are two values there, but I can see the actual values. But like a histogram, I can also see trends. So I can see there's 2 data points in the 60s, there's 6 data points in the 70s, and so on. If you were asked a question like this one here, what is the median score for this set of data, you'd have to take each of these data points and list them in order from least to greatest. When you do so, you can cross off numbers from the bottom and the top to find that middle data point. You'll notice, like before, we have 2 numbers left in the middle. So I would add 79 and 81 and divide it by 2 to get the median value. You might be asked to create some of these data plots yourself. Here's an example of something you might be asked to do. If you are given a list of data points and you're asked to create a dot plot or a histogram or a stem and leaf plot, this is what you would create. All of these data values look different when they're plotted in these different formats. The dot plot actually keeps track of the actual data. The histogram shows you a zone or interval which contains the data, and the stem and leaf plot sort of does both, where you can see the actual data points and you can kind of see what intervals they're in, 60s, 70s, 80s, 90s, 100s.